Hello, my name is Barry Hickey, and in this video I am going to draft a question showing an oblique cutting plane cutting through a cylinder. To do this, I'm going to relate it back to last week's principle sheet by using an auxiliary elevation method. This will also link to my last video. As you can see, I have my plan already drawn. I have my horizontal trace, my vertical trace, my XY line, and I have lightly drawn in my elevation. So in order to find an auxiliary elevation of this object, I need to follow along the horizontal trace. The horizontal trace is a horizontal line where the oblique plane cuts the horizontal plane. So if I follow up here at 60 degrees, because this is the angle of my horizontal trace, and draw my XY line perpendicular to this X1, Y1 line, excuse me. Draw this in perpendicular and darken it. It's my X1, Y1 line. So now I want to make sure I have enough space, 78. Just about. I'm going to run into my margin. I'm going to bring up my points. I'm going to bring up my center and my two extremities of the cylinder. Now, when I'm looking for my heights, I always go back 2 views. So back to my plan, back to my elevation to get the height of my cylinder, and carry that across. So now I have the height of my cylinder in the auxiliary view. This, revert this heavy line. This is my auxiliary elevation of the uncut cylinder at the moment. Now, I want to take a measurement of, I want to draw in my auxiliary or my oblique cutting or oblique section plane. So I take the distance of it from the elevation and project it onto this line. And I also want to get another point on this another point on the vertical trace in order to find it in elevation, or in the auxiliary elevation. That is here. So I want to label this as my vertical trace. what I want to do now is divide up my plan just to find points on this auxiliary elevation that I can reference in both my plan and my elevation. So I'm going to divide it up into 12 using my 30 and 60 degree set square. One of the most important things to do now is to label all my points, because this will, by the time we're finished, there will be a lot of lines moving around the page. So now I want to project all these lines up to hit my vertical trace in my auxiliary elevation, and they want to go parallel to my horizontal trace. As I bring them up, I'm going to label them, their numbers. Outside edge is 2. So now that I've found where each of these points on my circle in plan cuts the vertical trace in the auxiliary elevation. So when we brought our points from the elevation to the auxiliary elevation to find the height of the vertical trace and the height of our cylinder, I'm now going to reverse that and bring my heights from my elevation, or my auxiliary elevation, back to my elevation to complete the elevation. So I'm going to bring up all my lines. And I'm going to label them. So 8 and 10, 11, 3. Last step, the second last step now, is to transfer my points, my heights from my auxiliary elevation back to my elevation. To find what the cut surface looks like from this oblique plane. It's 0.9, I forgot to label. 0.9. No, sorry. 0.8. Nine, 10, 11, Yeah, now I have all my, up here it's 0.8. Point 8. Point 9 and 0.7. Point 6 and 10. So 6 is here. 10 is here. Point 5. 0.11. 0.4 and 0.12. 1.3. Finally 0.2. So now what we want to do is join up these points with a freehand curve. So this surface we have found here is the shape of the cut surface in elevation. In plan, the shape doesn't change because no matter what shape it is, if we look at it from the top, it'll still remain to be seen as a circle because of the cylinder is a circle. So just to finish, I want to heavy in my elevation. From observation now, I don't think this is correct because my vertical trace shouldn't cut through this piece. The surface should be look in elevation as if it's just below the vertical trace. This is something we're going to have to review. Thank you.